The first theorem, if the derivative is always 0 for the interval, then it's a constant. We talked about how yesterday I drew a picture where we're looking at our different theorems, and you know if the derivative is always the same, that means your graph is a horizontal line, so it's a constant. If f prime and g prime are always equal in the interval, then if you subtract them, you get a constant. And that's something we kind of talk about with derivatives. If your derivatives are the same, the only difference could be the constant for your function. You know, x cubed and x cubed plus 5 have the same derivative because the constant has the derivative of 0. I really just want to do this last example. So we need to see if the mean value theorem can be applied. That's like the first couple questions on the handout that I gave you yesterday. The first ones are saying, see if it can be applied and then do it. We need to see if our requirements are met. What are the requirements for the mean value theorem? Continuous, differentiable, and then for the Rolle's theorem, we have the condition that the endpoints had to be the same. For the mean value theorem, we don't have that third condition. So we need to check 2 requirements. First is that it's continuous. Keep in mind, this is like negative x squared over 3x plus 6. So when you're looking at where it's continuous, you're really looking at where would this not exist? Where does this not exist? At negative 2. Is that in my interval? No. So you could just tell me it's continuous. I'm going to say has to be continuous on the closed interval, so continuous at your endpoints. I'm just writing a little more justification on test or quiz. All you really have to do is state that it's continuous on that closed interval, but you better be right. So when I'm trying to decide if it's continuous, I'm really just looking at where is it not defined. If that's a fraction, that's just where is the denominator 0. Okay, second thing, it has to be differentiable. So I'm going to come down here and actually find our derivative and see where that exists. So to do this, we're going to do quotient rule. So low, d high, derivative of the top is minus high, d low, derivative of the bottom is over low squared. So if you distribute, this is differentiable as long as that derivative exists. Where is this not differentiable? At negative 2. It's a fraction, so it's not continuous and it's not differentiable at the same place where the denominator is 0, which is negative 2. That's not in my interval. So it is differentiable on the open interval like required. It's the dust. Okay. Any questions on those 2 pieces? Or how to find out if it's continuous or different? So, we have met the 2 requirements. So the mean value theorem, a lot of times I'll just abbreviate that MVT, excuse me. That applies. We can do it. For the mean value theorem, what do we have to do? the slope of the endpoints. What it says is that somewhere the derivative equals the slope of the endpoints. So my endpoints are -1 and 3. If you plug a -1 into your equation, so the opposite of -1 squared over 3 times -1 plus 6, you get -1 third. If we plug a 3 in, we get the opposite of 3 squared. 3 times 3 plus 6. So -9 over 15, or -3/5. Make sure you're putting this into the original. So now we do the slope. y2 minus y1 over x2 minus x1. So we get -9/15 plus 5/15. So I get a slope of -1/15. Are you guys checking that? Don't believe everything I tell you, double check. So what this tells me is that the derivative has to equal -1/15 somewhere. So my derivative I'm going to cross multiply. Multiply those. Times 15, 180. This one, can I go ahead and FOIL this and take it times -1? So if you FOIL it, you'd have 9x squared, so -9x squared. Plus 18x and plus 18x, so 36x. Minus 36. So I've kind of skipped a few steps, but is everybody with me? Quadratic set it equal to 0. So if I add over my 45, we get 36x squared minus 36x. If you add over your 180, 144. Yes, I dropped an x, didn't I? Hold on. This right here is 180x. So add that over. So you have 144x minus 36. We want to try to factor that. Aren't all those divisible by 36? Are you sure? 144 divided by 36 is 4. Okay. Does this factor nicely? No. So what do? Quadratic. I had to give you at least one ugly one. So opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So that would be 16 plus 4, so 20. Can break 20 up into a 4 and a 5. Hey.
Did you get new lights?
Yes. Aren't they awful?
I can't even tell. I don't even know if I got new lights.
So divide by 2 and we get -2 plus a minus right. We need to know if both of those are in your interval. Why don't you grab a calculator and try real quick. If you do -2 plus the square root of 5, remember our interval is from -1 to +3. So is -2 plus the square root of 5 in there? Yes. Okay, do -2 minus the square root of 5. And that gives you a -4, which is not in our interval. So our final answer, we just had to find the one that worked, and that's -2 plus the square root of 5. Okay, that was nice and pretty and ugly, wasn't it? Any questions? Let's talk a little bit about our quiz. It's going to cover 4.1 and 4.2. Quiz tomorrow. If for some reason we get 5 inches of snow and I don't see you tomorrow, it'll be the next time I see you. So that means if you need to take something home so you can review, do that. No excuses. Next time I see you.
Will there be enough, like, will we have enough time in class on Friday to take one of the other matches?
I may have to modify it. It's what I would probably do. The front page will go really fast. The back page may take you a second longer. I'd probably just not grade the homework and hand you the quiz when you walk in.
So you're not ready?
Well, we will, but if I'm for sure you got time on Friday. Oh, I will collect it. But if I'm short time, I would prioritize quiz over homework. Okay, first thing, open up your books real quick, page 280. Okay, the first thing that we did was finding maxes and mins, so I would probably put a question like number 5 or 6 on there, asking you to look at it and identify local maxes and mins, absolute maxes and mins. Keep in mind, if we looked at number 6, can you have a local max or min at an endpoint? No. Okay, so absolute max, the absolute highest this graph ever goes, it would be when x is 0, but what's wrong with that? It's an open circle. So do we have an absolute max? No, you would tell me none. Do we have an absolute min? Where? At 4.1. Does everybody see that?
Yeah.
Okay. Local max. Remember, those aren't endpoints. They're just higher than the surrounding points. So local max would be at the ordered pair 3, 4, and the ordered pair 6, 3.
Do we have to put the ordered pair, or do we just put the x value?
I would want an ordered pair, an x and a y.
Would you like the f of 4
Yes,
equals
that's fine
2
as
or
well. Do we have local mins? Yeah, when x is 2, what's the y value? 2, 2, 2. It's that closed circle there. Do we have any others? 4, 1. It's both the local and absolute. And that would be the only other one. Okay? So we did, I think, 5 and 6 on our homework when we did those. Are there any questions about that? Yes, ma'am.
For the corners, would we still count that?
Yes, it doesn't have to be differentiable. It just has to be higher or lowest on the graph, so it still works. I might give you one like problem 7 and 8 where you had to draw a graph that meets the requirements. You know, we did one that we did a couple of those on the homework, but I said, okay, it has to have an absolute max when x is 3, an absolute min when x is 4 or something. So you can expect to have to draw your own graph for something. And then the other thing we did on here was finding our critical numbers and absolute maxes and mins. So if I just ran through a problem real quick. Let's say I gave you I want you to, let's do, okay, so what if I asked you to find the critical numbers of this? What would you do? Derivative. Okay, and you have to find out anywhere the derivative is 0 or undefined. If you have a fraction, it's undefined when the denominator is 0. No fractions, so that's not going to happen. But now I need to figure out where this equals 0. What would you do first? Take out your 6. Factor, multiply to -2, and add to -1. Okay, so my critical points are when x is, okay. What if I asked for the absolute max and min on the interval -2 to 3? Once you find your critical numbers, you have to check, are both of those in my interval? Yes. If they're not, then you ignore the one that's not. If I had like a -4, I just wouldn't use it. And then if you remember, we plugged those in, the critical point and the endpoints. We plug them into the original. So if you put a -2 in there, you get -3. If you put in a -1, you get 8. If you put in a 2, you get 19. And if you put in a 3, you get -8. So what's your absolute max? And the absolute min? What is that? So you should be able to find critical points. That's anywhere the derivative is 0 or undefined, and absolute maxes and mins. Okay, I might give you something with polynomial. I might give you something that is not. Now we did some where you had negatives come up in your exponent. You know, if I gave you this one and asked you to find your critical points, what would you do? Derivative. So exponent comes down, inside stays the same, subtract 1 from the power, times derivative of the inside of the 4. I recommend rewriting these. Negative exponent puts it on the bottom. If you need to, write it as a cube root. Squared. So my critical points are anywhere this is 0 or undefined. Critical points, does the top ever equal 0? No, so it's never 0. It's undefined when the bottom is 0. What makes the bottom 0? -2. So my only critical point is at -2. So just watch, if you have a negative exponent show up, just go ahead and flip it down to the bottom, and that'll help you figure out when it's undefined. So that was section 1. Maxes and mins, critical points. Are there any questions about that? Section 2, I'm going to tell you there will be 2 questions. There will be a mean value theorem question, and there will be a Rolle's theorem question. They're going to be pretty basic. I'm not going to try to trip you up on the theorem itself, so fairly nice functions. But the key is you have to know the requirements. that's where most of the points are coming from on those questions, that you're checking the requirements. So for both of them, it's continuous on the closed interval, differentiable on the open interval. If they're polynomials, it's easy. You can just say it's a polynomial, so I know it is. Otherwise, like the example we did, you have to check. Then for Rolle's theorem, you also have to verify that the endpoints are equal. So really the thing that you probably want to study, especially if for some reason we had a snow day, you want to make sure you know those two theorems. Because I'm not going to say, I'm just going to say, okay, verify this function meets the requirements for the mean value theorem and find C that makes it work. So you have to know what that theorem is. And those questions are worth 7, 8 points apiece. So make sure you know those two pieces. All right. So then you have your handout, and that'll help you practice the mean value theorem and the Rolle's theorem.